Okay, myself, I am Pavan Kishore. We have completed 23 years of services in water and wastewater. We have supplied 1,400 STPs and also exported a few STPs to various countries. And we introduced a few technologies. And also we introduced some technology like easySTP, wherein which we doesn't require any operator.
Thank you, Kishore. Thank you for that wonderful introduction. Good morning, everyone.
Good morning.
Visible. Great. Okay, sir. Today's topic is everything about sewage treatment. What is sewage? The basics, right? Like we discussed, thank you and welcome all of you. This is a very vast subject. We are going to discuss basic of the basics. From a layman's, that means somebody who is not from the industry, from a layman's point of view, we're going to understand what is sewage, why we need to treat it, and how to treat it. Right? This is what we're going to cover today. So let us understand what is sewage treatment. What is sewage primarily? Treatment is the next part. Right? What is sewage? If you break down sewage and see, it is 99.95% water and only 0.05% impurity. Please understand, it is 99.95% water. The impurity that we are trying to take out by way of treatment is only 0.05%. And many a times, because of this 0.05%, we throw away this 99.95% water. Just because of this 0.05%, we throw away 99.95% of water. If we can remove this 0.05%, this is normal water. All right. So sewage is primarily 99.95% water, 0.05% impurity. And sewage treatment is nothing but removing this 0.05%. So sewage treatment is removing 0.05% impurity present in water. So in one word, if you can just see the schematic, it is showing all the water coming from our human usage. Please understand, human usage. Non-human usage is called industrial wastewater, industrial effluent. But if it is coming from human wastewater, it is primarily sewage. And there are some segments where even if the activity is human, like hospitals, like hotels, like restaurants, then we don't call it sewage. We'll go into the definition as the time progresses. Okay, so what exactly is sewage? If you just look at the definition, it's a used water from community. Community means people, right? So used water that is coming from our drain, what comes out of our home. It can contain things that we have used while we are using water. Like for example, we wash clothes. So from the clothes, what is going into the water to make it sewage? One, soap. And when we wash our clothes, a small component of the fabric in an invisible proportion. And also some small oil and grease which are stuck to our clothes. Maybe some dust which has accumulated on our cloth. These are the things that are getting transferred from cloth into the water. So the pure water, it was before being used for washing, now it contains a large quantity of soap, a very small fractional quantity of water we are trying to remove from the fabric, that is oil and grease and dust particles. So this does not contain anything that is coming from outside. It contains basically things that we use on a daily basis. Okay. Now we are also saying the water that is coming from our drains and toilets. So what it means is, where all we use water in our home, first we use water for drinking. Okay. When we drink water, it comes out in the form of, urine. So urine is one thing that is coming out. Second is the toilet wastewater. When we flush, the water comes out along with fecal matter. Then from our hand wash, whenever we use water to wash our hands, maybe before lunch, before meal, after meal, right? Before meal, it is purely soap. After meal, it could contain some small particles of the food that we have consumed and whatever is stuck to our hand. Okay. Then we use it for washing our clothes. Then we use it for bathing. Then we use it for washing our utensils. So we use it for cooking. Sometimes we wash vegetables with our water. So all this comes out, and whenever it is coming out, it contains a very small invisible fraction of what it has been used for. If I am using water for washing a coffee mug, a small trace of coffee will go into the water, making it wastewater. Wastewater is the right word rather than sewage, because we have certain uh, bad experience or certain bad notion about sewage. Instead of calling it sewage, some countries now like Singapore have started using the word used water. Instead of calling it wastewater, they're calling it used water. Used water, from used water, water impurity is there. If you just take out, you can reuse the water again. You can use it any number of times, right? But the understanding is it contains waste products from daily human life. Unfortunately, there is a stigma attached to sewage. This stigma has come from our traditional background, wherein diseases were getting spread and there was no treatment for diseases. 100 years ago, there was no treatment for diseases, right? So, from that perspective, if you see, sewage was something like a time bomb. People dreaded touching sewage. That is still in our mind, and it is getting carried forward to our present generations. And let us also understand what is not sewage. Any water that is coming from industrial process, non-human activity. In an industry or in an office, there could be multiple activities. Like if it is coming from hand wash, coming from lunch, coming from canteen, then it is human activity. If it is coming from process, from our production shop floor, it is not sewage. It is industrial effluent. All right. Like RO reject. RO reject is not a sewage. It is a industrial process waste. DM plant wastewater. Again, it is not a sewage. It is industrial process wastewater. Even where the water is used in excess quantity for something like kitchen in restaurant, any major restaurant uses a lot of water for washing of utensils, for washing of their food products like rice, vegetables, chicken, mutton, all these things. So all that water is technically not sewage. Why so? Sewage means it's a combination of water coming from hand wash, coming from toilet, coming from laundry, coming from kitchen, a combination of all these things. If you take out only one of that, let us say you're using the water from restaurant. Restaurant water is rich in food particles. It is rich in oil and grease. It is rich in soap. So these are in excess quantity. So the ratios, the characters will be different compared to sewage. So it is not called sewage. So if you are setting up a treatment plant for removing those impurities in a restaurant, it is a effluent treatment plant, not a sewage treatment plant. The same logic applies for a hospital. In a hospital, apart from domestic usages, you will also have usages like there might be a laboratory which is washing their vials and samples. Then there could be operation theater, labor rooms, which are washed with large quantity of water, right? So the water that is coming from a hospital is technically not called sewage. Similarly, in a hotel, in a large 5-star hotel, you would have a effluent treatment plant as well as a sewage treatment plant. This effluent is something that is coming from a commercial laundry. In a commercial laundry, you have a lot of strong, ultra strong detergent and very little of other biologically degradable impurities. So as a result, that does not qualify as sewage. So it is not sewage. Let us understand very clearly what is sewage and what is not sewage. Let us look at the historical perspective. That means historical perspective means traditionally what is sewage. If you look at all our civilizations, right from our Harappa, Mohenjo-daro and Egyptian civilization 4,000, 5,000 years ago, all the civilizations have settled next to a river, right? Why was it? First, there were no means of getting the water from the river, so they have to live close to the river. And second thing, if you remember reading history in our 8th class, 10th class, our Harappa, Mohenjo-daro civilizations, Indus Valley civilization, they had drainages, not exactly underground drainages, above ground drainages only, where the water was being taken to the nearby river after usage. There were common bathing areas, right? So it simply shows that even during ancient times, 3,000, 4,000, 5,000 years ago, the people have realized the importance of water. They have realized the importance of wastewater. They did not mix water and wastewater. They segregated these two and dealt accordingly. Rivers were used for two purposes, primarily drinking, and a lot of us ignore that river water was the main source of transportation, let us say 1,000, 2,000, 5,000 years ago. It was also used as a means of disposing the wastewater. This is unsaid. Nobody said clearly. If you just look at any major city in the world, I'm saying the world, Hyderabad on Musi River, Delhi, Yamuna River, Calcutta, River Ganges, right? You look at any major city, it is there only on a river bank. What was the reason? The primary reason is people wanted water for all their purposes. And also they wanted the river to dispose the used water. These two are unsaid. Now comes the challenge. If a particular community, let us say we are disposing our used water in our Musi River, this Musi River, where does it go? It is not exactly going into the ground. It is going and joining another larger river, a bigger river. Maybe it goes and joins Krishna, right? This Musi is a small subsidiary. It is going and joining Krishna River. So the sewage or some of the sewage which is not being treated at Hyderabad in the Musi River is going and joining Krishna River. And this Krishna River is carrying the untreated sewage of so many other cities like Vijayawada, right? And this is again in turn becoming a drinking water source for downstream cities. This is where the challenge is. The challenge is if we are drinking untreated sewage, we are being subjected to numerous diseases, which some of which are visible immediately and some of which are long term. And when we are using this water, the untreated sewage containing in the water is being used for agriculture. The farm produce, like the vegetables that are grown using untreated sewage, they are highly dangerous for human health. This is the reason number one why we need to treat sewage. Sewage is like air pollution. Air pollution is there. Everybody goes through that. You cannot prevent. You can't say I'm escaping from air pollution. In the same manner, if you just look at any city, every city has a lot of lakes. And if you're from a rural background, you would have seen lakes in your village also. No village lake has water in summer. Every city lake has water in summer. Where is this water coming from? It is coming from our sewage. And where is the sewage going? From the lake. It is going into the underground strata to our bore wells. So indirectly, without realizing, we are all victims of untreated sewage. 99% of us do not know this. We are not aware of this because our education is not telling us this. Untreated sewage, first culprit is people who are living in every city. Every city has the same problem. If you check your groundwater, your borewell water, it contains what this sewage contains. It is not exactly water. All right. So as cities are increasing, now why sewage treatment was necessary 100 years ago? This kind of populations never lived close to rivers. Most of the people were living in rural areas. Now in the last 100 years, because of this industrialization, migration to cities, urban areas has increased, and it has increased manifold in the last 20 years. So every city now has more people than it can handle. And where is all the wastewater going? It is going into the river, which is flowing through the city. And this river is carrying all the impurity. Previously, it was carrying maybe 10 million liters per day. Today, it is carrying 100 million liters per day, 500 million liters per day. It is beyond the capacity of the rivers to naturally purify this wastewater. Now, what is the natural purification? We'll get to that in a minute. In the next few slides, we'll discuss that. Right. So what was sustainable previously? Rivers were capable of treating our sewage when the quantity is small. Today, rivers are not capable of treating that sewage. Okay. Along with sewage, we are also having additional wastewater sources like restaurants. I was told Hyderabad has something like 10,000 plus restaurants in Hyderabad. So all these 10,000 plus restaurants, imagine cooking, washing of their utensils, throwing so much of oil and grease, oil, food particles. Where is it going? Through the drains, it is going into the river. Okay. And factories discharging their wastewater, laundries discharging their wastewater, so many cars being washed every day. Every car wash will use a lot of soap oil. The soap oil along with water is getting into the river. So rivers are overloaded. Maybe they are overloaded 1,000 times beyond their capacity. All right. So what we are seeing here are basically sources of sewage: homes, factories, hospitals, restaurants, and also rainwater. You might say, how is this rainwater source of sewage? When it rains on the road, it is carrying a lot of those dust and tar, whatever is lying on the road, into the drain, from the drain into the river. Okay. Now, we just discussed this point. Let me move forward a little faster. When we talk about sewage, how much sewage is generated from each source? On an average, a person uses about 150 liters of water every day, if there is running water in our home, right? 200 is taken little on higher side. On an average, again, in an office, a person uses about 30 liters of wastewater every day for hand wash, toilet flushing, etc. Hotels, if you are talking about 3-star to 5-star hotels, they consume about 400 liters per room per day. This is per room calculation. Again, hospitals per bed calculation, 300 to 600 liters per bed per day. Because one bed might have a patient, but along with the patient, there are attendants, there are staff, there are visitors. All this put together becomes 300 to 500 liters to 600 liters per day, depending on the category. Okay. So much of wastewater is generated. What is the authentic source of getting this information? How much of wastewater is generated? On your right side, you are seeing manual on water supply and treatment systems. This is published by Central Public Health and Environmental Engineering Organization, CPHEEO. CPHEEO is a Ministry of Urban Development department. It's a government department. They publish this data as to how much quantity of wastewater is generated. Okay, you can go to this and check up, download, because sometimes for statutory purposes, we need to understand how much of wastewater is generated based on the source. All right. Now, the same thing we discussed just now. Let me move forward. Till now, we discussed how sewage is, what is sewage, from where it is coming. Now, let us move on to how to treat this. How means what exactly are we going to do this? Okay. So what is there in sewage? If you understand, sewage contains physical, dissolved, microbial, 3 types of impurities. What is a physical impurity in sewage? When we are washing a cloth, a small particles, dust particle which is there on the fabric is going into the water. When we are washing our utensils, when we wash our hand after meal, whatever has been stuck to our hand, the rice particle or the dal particle, whichever, it again goes into the water. Apart from this, water also contains a lot of sand. When we are talking about sewage, we are not talking about sewage treatment only from our home. Let us look at a larger perspective. Sewage treatment at a municipal level. A municipal sewage treatment plant, which is at the end of the city or which is at the end of the colony, is carrying water from open drains, closed drains. It is carrying water from restaurants. It is carrying water from semi-industrial commercial establishments like car washes, like our hotels, hospitals, right? So from here, a lot of soap can come. But soap is not a physical impurity. Along with this, when we say physical impurities, it is primarily wood particles come, some metal particles, plastic covers, baby diapers, sanitary napkins. These are the physical impurities that get carried along with wastewater. And these things need to be taken out before you treat water, because they can physically damage the pumps. For example, a cloth particle can choke the pump. The impeller will stop running, the motor will run, and it will burn out in the process. And if there is a lot of sand means we call it grit. If the grit is there, the impellers wear out in a matter of couple of months. What should last 5 years, 10 years will wear out because of the grit, sand. These are physical impurities that need to be taken out. Then there are dissolved impurities. Dissolved impurities means basically like your soap, fat, oil and grease, the smaller suspended particles of our food. These are the dissolved impurities. How do we take out dissolved impurities? We'll go to that in a while. And also it will have a lot of microbial contamination. What is microbial? It is a living organism. It could be bacteria, virus. Some of them are pathogenic, some of them are harmless. Majority of them are harmless, very few of them are pathogenic. Now, we are going to understand in the next few minutes how we are going to remove all these three different types of impurities. Right? We measure the presence of suspended solids or physical impurities. That means things that can be filtered out using a 5-micron filter paper are technically called the physical impurities. This is also called, in a larger context, the total suspended solids, TSS. This is measured in milligrams per liter, parts per million, ppm or milligrams per liter, right? Smell is again caused by, it is not a impurity per se, but it is caused by bacteria. It is caused by oil and grease. When oil and grease does not allow atmospheric oxygen to get into the water, it generates a foul smell. All right. Now, how we are going to remove? Let us go to that a little later. We discussed about one, physical impurities, then dissolved impurities. Dissolved impurities are basically coming from our food and the soaps that we are using. And finally, the microbial impurities. Microbial impurities are coming from our fecal matter. Fecal matter means the human shit, what we call. This is a fraction of the total wastewater, but it is coming from the main source is that. Then also, nature has a way of treating wastewater. What does it mean? Nature has a way of treating everything. If you leave a dead animal somewhere outside, after a few months, if you see, the dead animal is no more there. Some bacteria is coming and eating that. Vultures are coming and eating that. So nature has a way of, removing what is not useful in the nature. Okay. So this is accomplished by another living organism. You just imagine you leave a small lump of sugar on your kitchen platform. In 5 minutes, ants will come. 10-15 minutes later, flies will come. How do they know that there is some food there? So every living thing has two basic functions. One is reproduce, survive and reproduce. For survival, they require food. For reproduction, they require food. These two things happen naturally. So wherever food is there, microorganism will come and eat it. We don't have to do anything extra to attract them. We just have to create favorable conditions, right? If we just have favorable conditions, the bacteria will proliferate on its own. And how bacteria grows is it multiplies in geometric proportion. 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16, 16 becomes 32. It keeps growing in that geometric proportion. So within no time, a lot of bacteria will grow. It will eat off whatever we are trying to take away. So even if we don't do anything, wherever there is food, bacteria will come, try to eat. So the moment there is some food in water, in dissolved form or visible form, bacteria is always attracted. So whether we accept it or not, whether the water goes into a treatment plant or not, bacteria come and eat sewage. Then you might ask, when there is bacteria in nature, why do you need sewage treatment plant? Bacteria has a process time, right? And bacteria has limitations. It can eat only so much. Bacteria is a unicell organism. It can eat maybe another unicell, equivalent to another unicell. If you are giving too much food, they tend not to consume. So much of bacteria may not be able to grow there in the required time. So we are overloading our water resources beyond their natural capability. This is the reason why we need a treatment plant. A treatment plant is nothing but a way of removing that 0.05%, whatever is excess in the water, we are trying to remove. Now, we are simply replicating or speeding up a natural process. When we set up a STP, we are simply replicating and doing what nature does. The only difference is we try to do it faster. Okay. Every living thing, like we discussed, requires food and oxygen. Right? Without oxygen, there can be no living, there can be no life, there can be no survival. So where does oxygen come from? Again, comes from atmosphere only. We can't make oxygen for sewage treatment. We'll be using the available oxygen. So what happens in a river is there is oxygen in the nature. That oxygen gets transferred, some small percentage of it goes into the water. Water is a universal solvent. So it always has a small quantity of oxygen, 3 to 5 ppm of oxygen dissolved in it. This dissolved oxygen is used by these bacteria. They grow. Food is coming from the wastewater we are throwing away, and oxygen is available naturally. But in a treatment plant, what we are doing is we are taking the external source of oxygen, pumping extra quantity of oxygen into the sewage so that bacteria grows much faster. Food is available, you're maybe making available more oxygen, so the bacteria growth is much faster. In one sentence, if we were to summarize what is sewage treatment, it is nothing but providing more favorable conditions for bacteria to grow in required quantity and eat whatever you are trying to take away, whatever you are trying to remove. Right. Then let us look at a chemical characters, chemical or dissolved impurities. We measure the concentration of degradable content by something called BOD, biochemical oxygen demand. And then we measure non-degradable content. The non-degradable content primarily comes from our soaps. The soap is used in our bathing. It is used in our washing of clothes, washing of utensils, shampoos. So all these things contain COD. COD means something that naturally cannot be digested. Bacteria cannot reduce COD on its own. Most of the bacteria. There are certain types of anaerobic bacteria which can reduce COD. That is what is done in a sewage treatment plant. We use both types of bacteria, right? And we also use a lot of acids in our toilet cleaning, etc. Those acids could mildly increase or decrease the pH of sewage. Okay. Then comes the microbial impurities. Finally, microbial impurities means the bacteria. Where does it come from? It comes from our fecal matter. Our intestines are full of bacteria. All our digestion happens only with bacteria. We grow bacteria in our intestines to break down the food. So our human intestine is a big source of bacteria. And some of this bacteria goes out in the fecal matter. This is the primary source of bacteria in sewage. Now, some of this, if a person is ingested with some disease, he would carry the disease causing bacteria, which is actually the dangerous part. We call it pathogens. All right. Okay. And it also contains, last but not least, it also contains certain level of nutrients. Nutrients means nitrogen, ammonia, phosphate. These are the things that are also present in wastewater. Why we need to remove this? Because excess quantity of nitrogen is harmful for nature. Lot of weeds, if you see any lake in city, lot of weeds grow in that. Those weeds prevent sunlight from getting into water. They prevent oxygen from getting into water. As a result, there is no microorganism in water, and water impurity was supposed to be taken out. It does not go out. So that is how it pollutes. All right. Now, how is sewage treated? We discussed previously, sewage treatment is nothing but a natural process. A natural process means we grow bacteria so that bacteria will eat what we want to remove from water. What we do is we create a favorable condition in sewage treatment plant for the bacteria to grow. What is a favorable condition? You require oxygen. So the oxygen is provided by our air blowers from external sources like air compressors, air blowers, etc. There are multiple technologies for treating domestic wastewater, but all the technologies have one thing in common. Except for one or two, all the technologies use bacteria. They are all natural processes. They are all modifications of a natural process. Even a septic tank which is used in a village, a septic tank means where we are allowing sewage to enter, nothing is done. It is just stagnant. One type of bacteria will grow, anaerobic bacteria, which does not require external source of oxygen. It will break down oxygen available in water and grow. It takes oxygen and grows. But why not use that completely? What is wrong with septic tank? This can only remove 60 to 70% of the organic content. Number one, challenge number one. Challenge number two, it generates a foul smell because it generates methane gas in the process, methane and hydrogen sulfide. The rotten egg smell that we get near sewage treatment plants is caused by anaerobic bacteria. And most of the lakes that we see in our urban areas are infested with anaerobic bacteria. Why anaerobic bacteria? You might ask, water is, oxygen is there in the atmosphere. So the atmospheric oxygen could be available maybe up to half meter, 1 meter of water depth. And even that, some of that is prevented because we have a lot of leaves which are grown due to excess quantity of nitrogen and phosphate in water. Those are preventing oxygen going into water. If the tank is deeper, if the lake is deeper than 1 meter, there is no possibility of water getting oxygen from atmosphere. As a result, anaerobic bacteria grows. This is the reason why your lakes will be stinking. Whenever you go close to a lake, you will notice a stinking smell, a rotten egg smell. This rotten egg smell is coming because this anaerobic bacteria is releasing hydrogen sulfide gas. Okay, but again, this is a natural process. If there is no alternative, right? Please understand, if there is no alternative, if there is no power, let us say, we cannot give external source of oxygen to bacteria, then even anaerobic bacteria growth or the septic tank is good enough. 70% treatment is better than zero treatment, right? And what we are going to discuss in the next few slides is what are the various methods of sewage treatment. First thing that we come across very traditionally is called a septic tank. Septic tank means two tanks primarily. One tank to retain solids, the heavier particles settle down in that. The clear water goes to the next stage. So a two tank system where there is a partition provided. And in the traditional days, they were allowing the clear water to go into the ground. Whereas the physical impurities were retained in this tank, the clear water would percolate automatically into the ground. This is one process which is very popular, very prominent, and our governments have been stressing in the last 20, 30 years. So almost every village is now covered with septic tanks. Now there is a variation of a septic tank called jokasu. Jokasu in Japanese means purification tank. What is this improvement on septic tank? This is also called a aerated septic tank. That means one part of the system is septic tank, second part of the system is something like a MBBR. Okay, this is called a hybrid technology. This jokasu is a hybrid because it uses two technologies, one aerobic and anaerobic. 70% of the treatment is done in anaerobic process. That means without requiring an external source of oxygen. Remaining 20 to 30% of treatment is done by aerated process. So compared to any other process, this process consumes less power. It has less mechanical equipment. Then some countries like Indonesia, Vietnam, Malaysia have been using what is called a rotating biological contactor, RBC. This RBC is still used in those countries. Somehow India has not been very successful in developing the right kind of RBCs. The advantage in RBC is, again, it uses naturally available atmospheric oxygen. There is no forced feeding of air. It just have something like a disk. The disk is repeatedly going into water. It is going out. It is rotating in a central axis. So as a result, what happens is, for a moment, the disk is in sewage. Next moment, the disk is outside. So the bacteria is getting required oxygen from outside only. This is one of the ways. Each process has its own advantages as well as disadvantages. And again, one more very traditional method of sewage treatment is called extended aeration. That means you just have a shallow tank where you are providing a small quantity of air. The tank is very shallow, typically using atmospheric oxygen. And the later modifications into that came slightly deeper tanks, maybe up to 3 meters deeper tank with aeration provided from outside. and settling tank provided after the biological process. And then a later development is moving bed bioreactor, MBBR, very popular process. What it has is, like we discussed, it requires, first thing it requires is bacteria for sewage treatment. Second thing it requires is oxygen. So for bacteria growth, there are two concepts. One is called attached growth. Second is called suspended growth. Suspended growth means the bacteria is there suspended in water. Bacteria, as we all know, is a unicell organism. That means it has only one cell. It is not even visible to our naked eye. So along with the water, it would go out. Okay. So it is always a challenge to get more and more bacteria to come and grow in your process tank every day on a continuous basis. So what was some scientists did is they started putting some media are like, plastic sheets kind of thing. Just give me a second, please. So some plastic sheets, just to make sure that sufficient quantity of surface area is available for bacteria to grow. So this increased bacteria being available in water and reduce the tank sizes, right? And air was pumped from the bottom of the tank using diffused aeration. So this diffused aeration caused more oxygen to remain in water. The bubbles were coming in smaller size. A smaller bubble would remain in water for a longer time. So the process is a much more advanced, improved, efficient, energy efficient process compared to extended aeration. The MBBR would be probably, the tank size would be half, the blower requirement would be half. But then there are more different type of technologies like, sequencing batch reactor. We realized by now that all sewage treatment processes are natural process. So you can't tell the bacteria, now there is food available, now next 1 hour there is no food available. But if you look at certain type of applications, let us say there is a function hall. In a function hall, there can be function for 3 days. The 4th day, there is no function. 5th day, there is no function. There is no water. There is no sewage. Then there can be a hotel and hospital. In a hotel, there is more occupancy on weekend, or the remaining days, there is no occupancy. There is an IT park where Saturday and Sunday are holidays. There is a school and college which are not working on Sundays. There is a shopping mall which is overloaded with people on Sunday, Saturday, Sunday. Monday, there is not much of crowd. So it is becoming a challenge to balance and maintain sufficient quantity of bacteria for treatment. So for such kind of applications came what is called batch reactor. That means when you have sewage available, you will give it into a process tank and treat it. And when there is no bacteria available, just give me a second, please. Yeah. Am I audible and visible? Please confirm. Kishore, could you
Yes, sir. Yes, sir. You're audible, sir. Yeah, yeah.
Okay, because my
Yeah, you're
camera
audible.
was showing I'm not available. Okay, fine. Okay. Yeah, thank you for the confirmation. Right. So certain type of applications like this sewage being available on one day, not being available on a different day, being available unequally on different days. This resulted in developing another process called batch reactor, a sequential batch reactor. This sequential batch reactor is primarily used in large capacity applications like our shopping malls, large capacity commercial applications like shopping malls, hotels, hospitals, and even certain municipal wastewater treatment plants, because the generation of wastewater is not uniform. Okay, for such cases, it is ideal. Then there is also something called decentralized water treatment system, DWATS. DWATS is again something similar to septic tank, but it's an advanced version of septic tank. In Jokasu, you are treating 70% of the water for anaerobic process, that is septic tank, 30% using external aeration like MBBR. In DWAT system, first part is 70% is septic tank. The second part is extended aeration. You are using natural atmospheric air. You are not using any external source of aeration. And you might also use certain plants, some plants which increase the oxygen level in water. So in a DWAT system, the second part of the oxygenation is done using either plants or using naturally occurring oxygen. Okay. And above all these things, there is also one more process called electrocoagulation. Okay, electrooxidation or electrooxidation, which is totally different from all these concepts what we have discussed. All other processes use bacteria to eat and remove what we want to take out. Whereas electrocoagulation works differently. There is no bacteria in the process. It uses electricity to treat the water. Right. So it is totally different. How and why is something that we will discuss in some of the coming sessions. Which is better? What are the advantages, disadvantages of each of these processes? Right. We'll get into that in the next few sessions. Okay. So let's understand which technology is suitable for what application. Right. I'm not going too deep into what are the advantages or disadvantages of technologies, because we have only something like 45 minutes and that much of time is not enough. We are almost getting close to our 45 minutes. Let me wrap it up in the next 5 minutes. Okay, let us see where septic tank can be used. Septic tank is suitable only for small capacity applications. It can remove up to 70% BOD, but it generates a mild foul smell because of methane and hydrogen sulfide. And there is no capital cost. It does not even require a power connection. These are the advantages. Where it can be used? It can be used where you don't require extremely good quality treated water, where there is no problem. You know, your toilet, maybe in a farmhouse, you have 1 or 2 toilets, or you are in a remote area, hilly area, where power is not possible. Okay, in such cases, a septic tank is still recommended. But a septic tank is not a sewage treatment plant. Please understand this. Septic tanks are not permitted by Pollution Control Board in urban areas. So if you are trying to set up a STP in urban areas, then septic tank alone will not be sufficient. So a septic tank can be used for cases where there are 1 to 2 KL per day sewage treatment. All right. It's only for, recommendation is only for very small capacity of 500 liters per day, 1000 liters per day kind of applications in rural areas. Okay, now let us move on to the next treatment process called Jokasu. Like we discussed previously, Jokasu is a hybrid process of anaerobic and aerobic. So by definition, it is more efficient, but it still uses a small quantity of energy because a small blower is used, but it doesn't have much of electromechanical equipment like MBBR or SBR. It uses a small air blower. And biggest advantage of this is they are very compact, they are factory made, right? And they reduce BOD up to 95%, right? And they are all factory made. So there is a standard in manufacturing. In Japan, a very small country, Japan is a very small country in terms of area, maybe it is less than 10% of Indian population, Indian geographical area. Every house is either connected to a municipal sewer or it has its own sewage treatment plant. Like we have our domestic RO in our home, every house in Japan has a Jokasu. As per Japanese government statistics, 80 lakh plus Jokasus are working in Japan. So they have, in the last 30 to 40 years, this Jokasu technology has developed rapidly. And in India, we are trying to adopt this Jokasu in a large scale because every house needs to have a treatment plant. So it's not possible for every house to connect to municipal drains. Why it is not possible? Again, maybe one of the other sessions we'll get into that. One major advantage of Jokasu is it does not require an operator. The power consumption is something similar to our ceiling fan. The capital cost is also not much compared to a large capacity municipal sewage treatment plant. So this is ideal for small volume places like, school, college, a small factory, a small residential colony, a small gated community. These are the kind of places where Jokasu is ideal. We normally recommend Jokasu up to 50 KL per day. Up to 50 KL per day, we don't recommend any process other than Jokasu. But what is on the negative side? There are not many manufacturers in India at this point of time. Indus Ecowater is proud to be the first manufacturer of Jokasu in India. And even today, there are only 5 to 6 manufacturers of Jokasu in India. Compared to the potential, it is a fraction. We need a country like India needs almost 100 plus Jokasu manufacturers who are making at least 1 lakh units per annum. That is a volume that is possible with Jokasu. In Japan, there are 14 manufacturers who make 1 lakh plus units every year. They have that kind of installed capacities. Now let's understand a little bit more about our MBBR process. MBBR stands for moving bed bioreactor. Again, reduces BOD up to 90%, right? It's good for constant load conditions. Constant means every day the sewage generation can be the constant. Plus or minus 10% is all right, but not 30-40% swings. When you have that kind of swings, you need to go for SBR. So residential apartment kind of things, you have more constant load. Maybe one person is gone on a vacation, one new guest has come in a home. But otherwise, all residential setups need to have an MBBR process. Compared to other processes, this uses less operator skill. Less operator skill is required to keep the plant functional. And the operating cost is also low. The capital cost is also relatively low. If you combine this with ultrafiltration, it gives you extremely good quality water that you can reuse, right? And what are the disadvantages? It requires huge process tanks to be constructed in RCC. Power cost is also high, and operators need to have certain level of skill. And what are the capacities suitable for this process? Anything above 50, but up to 500 KL can be ideally treated with MBBR process. Okay, now let's understand SBR, sequential batch reactor or sequencing batch reactor, as some people would call it. This again reduces BOD by 90%. Both MBBR and SBR reduce BOD only up to 90%. Okay, any biological process with the exception of Jokasu reduce only by 90%. Please understand. Jokasu, because it uses both anaerobic and aerobic processes, gives you better quality water. All right. Okay. Now we are discussing about SBR. So reduces BOD up to 90%. It's great for variable loads like our hotel, hospital, shopping mall, or our function hall, and even for large capacity municipalities where the loads are uncertain, right? For that kind of a thing, SBR is ideal. MBBR cannot be used irrespective of the capacity there. Okay, but what are the disadvantages? When you are saying batch, it means you need instrumentation to understand when your batch is, the volume of batch is available for process, and the process should happen in limited time. So your civil works cost is extremely high, the highest probably among all technologies. That means you need more equipment, more instrumentation, more automation, and as a result, the operator skill also has to be high. A conventional, untrained, unexperienced operator cannot maintain a SBR. Again, if you combine ultrafiltration along with the SBR process, it gives you extremely good quality water suitable for reuse, right? Now, again, what is the disadvantage? Civil works, cost of civil works, there is power cost, and there is operator skill, and also sometimes time. If you are in a hurry, you can't set up a SBR. Now, a lot of people have been talking about membrane bioreactor, MBR. It seems to be a fashion to people, but please understand, MBR is not a process by itself. MBR is nothing but MBBR plus membrane for filtration. The biological process, the core, the heart of any MBR is MBBR. To remove the organic content, you are using MBBR. Then to extract better quality water, you are putting a membrane, ultrafiltration membrane into the water, creating a vacuum. Because of the gradient pressure difference, clear water is getting into the membrane and being taken out. The same result can be achieved even if you set up a external source of membrane after MBBR or after SBR. Okay, this is what most of us would be recommending because MBR is expensive. It gives you high quality water. The capital cost is extremely high compared to MBBR, SBR. Your equipment cost in MBR is at least 3 to 4 times, and it has a lot of automation. So equipment plus automation, that means more operator skill. Highly skilled operators are required. The membrane replacement cost is also extremely high because very few manufacturers are there in the world. There are some people who want to show that we have high-tech equipment. That is the kind of people who would probably go for MBR, right? And personally, as a STP vendor, we don't recommend MBR. We normally recommend either go for SBR or MBBR and then put a external ultrafiltration membrane. Save on cost, save on you are decoupling both the processes, and you save on the replacement cost also. So in short, now we discussed about multiple technologies. There is nothing like one technology is perfect, so it suits all the requirements. There is nothing like that. You have to choose the technology or process based on your specific requirement. For this reason, we normally recommend customers to discuss with vendors, right? The vendor should understand clearly what is the nature of sewage generation and what is the objective of treatment, why we are treating. We just have to treat it and throw it into the ground for irrigation, then any conventional process is good enough. If we want to reuse the water for toilet flushing or any high-end use like cooling tower, boiler feed, then the technology has to be more advanced. But the process remains same. The biological process is always same, SBR, MBBR, Jokasu, or whatever it is. Then comes the next steps. This is what a vendor has to define and advise the client which technology is suitable for them. And please understand, my final thought is every problem is an opportunity. If there is a problem, solving the problem creates an opportunity. Opportunity for business owners, opportunity for their employees. So problem is equal to opportunity. When there is no problem, there is nothing for you to solve. So when there is a problem, we get paid for solving these problems. When we get paid, our employees get paid. That means every problem generates business, and that business in turn generates employment opportunities, right? And I personally believe that sewage treatment is not just a business or not just a work. You're doing work for the betterment of the community, betterment of the society. It is something we make a living, and we also help the environment, which a lot of other processes, other businesses do not offer you that kind of flexibility. All right. Now I am ready for your questions. Your questions, please. Kishore.
Hi,
Questions,
everyone. Yep. Please. Now we have a time of 10-20 minutes we'll take. Yeah. Thank you, Ishanji. Please ask your questions. We'll share the details. If you have any questions, please do ask us. And also, please share your contact details and mail ID. Only few people have received. Others, if you have any questions, please ask.
No
Anyone,
questions
please.
means either I have failed miserably to explain anything, or you have understood 100% of this. One of the two is correct.
I think all are okay. Anyone say?
Sir, this is Swami.
Yes, Swamiji. Please go ahead, sir.
Sir, I have a small doubt in clarifier,
Okay.
in MBBR clarifier.
Okay, sir.
So in clarifier, tube settlers are required to mandate the sludge settling process,
What is the capacity, sir?
80 KLD.
80 KLD. So let me explain. Tube settler is doing, what is it doing? It is providing you a more surface area, right?
Yeah.
For your particle to settle. If you are manufacturing a very small plant, or if you are installing something like a 20 KL STP in a compact area, in a very small, let us say a prefabricated STP is there. This tube settler concept came up only for compact areas. Now, I am personally against tube settlers because tube settlers might improve the efficiency of your settling initially, but whatever we are trying to remove, the suspended impurities, form a layer, and over a period of 2 to 3 years, they choke the tube settler completely. Tube settler has maybe 1.5 inch size square holes, right? When you put that in a 45-degree to 55-degree angle, there is a small hole in the process. That holes get choked with the suspended particles. So as a result, the tube settler water becomes septic. I have seen many installations where tube settler media has to be replaced after 2 to 3 years.
Yeah.
So if you are manufacturing or if you are installing something new, if there is a space problem, then go for tube settler. If there is no space problem, go for conventional, either rectangular clarifier. If it is a large STP of 300, 500 KL, better go for those circular clarifiers. They'll give you a lot more clear water.
Okay.
If you look at municipal STPs, they don't have tertiary treatment. Most of the time, at the outlet of biological treatment, that is secondary settling, the water is discharged after chlorination.
Thank you, sir.
Thank you. Thank you for asking. More questions, sir? Abhilash ji, from your end, any more questions?
Yes, sir. I have one doubt.
Yeah, please.
So in regular this treatment process, it will reduce the BOD up to 70%, right?
No, sir. 70% is what is happening in a septic tank.
Yeah, septic tank.
Ji haan.
So in MBBR up to 90%, you have mentioned.
Yes, sir. MBBR is basically completely aerated process. It does not have anaerobic process. It is purely aerobic process.
Okay.
In residential uses, most of the time, people recommend aerobic process because anaerobic process can generate methane and some small quantity of foul smell. So for this reason only, they recommend only aerated process. But the disadvantage of aerated process is it requires more energy, more equipment.
Yeah.
More equipment means more power, more maintenance.
Correct. So what are the Japanese equipment you are recommending?
Ji haan.
Yeah. After using that, the treatment water again with the help of UF, you are recommending UF, right?
Yes, sir.
For reuse. Yeah, it is approved by our local PCBs or.
Sir, if you look at PCBs, no PCB ever says use this technology. They only ask you what is the treated water quality. And in Karnataka, PCB tried for some time, recommending 1 or 2 technologies. They were recommending they were recommending SBR and MBR.
Okay.
But after 6 months or 8 months, so many complaints came from other vendors, including government department themselves. They have to withdraw that GO. So PCB is technology neutral. They would not recommend any technology. They are not against any technology.
No, Suresh. Here I am asking that after UF.
Okay.
By treating this sewage water into this Japanese equipment.
Okay.
The treated water can be reused by incorporating UF, right?
Sir, when you are using the word reuse, you can reuse the water for various applications. Let me explain a little more detail. First reuse is we are using it for irrigation. Okay?
Yes.
When we are using for irrigation.
STP, after STP, right now we are using for irrigation only.
Irrigation.
For green belt.
Right, sir.
Yeah.
Right. If you are using it for irrigation, you don't require a very strong tertiary treatment. Even if there are some small suspended particles, it is all right.
Okay.
Same example, if it is a hospital where the water is used for landscaping, right?
Yeah.
As it is, hospital wastewater is full of patients. It is coming from patients. That means there is some level of pathogenic bacteria in that wastewater.
Yes.
And in our biological process, we are only increasing the bacteria. We are not killing more. We are increasing. We are creating more favorable conditions.
Yes.
Right. So this pathogenic bacteria, if it escapes our chlorination, or if our chlorination is not 100% effective, right? So it can go into the grass when you are using this water for landscaping.
Okay.
Good possibility?
Yes.
High possibility. Then the people who are going to come and sit on the lawns are also patients whose immunity levels are generally considered to be lower. Right? So if a hospital wastewater has to be used for irrigation, it must have next level of protection. That means the next level of protection is ultrafiltration plus a secondary disinfection. Like chlorine can be primary disinfection. Secondary disinfection can be sodium hypochlorite, VCO-chlorine. Secondary disinfection can be UV or ozone or both.
Okay.
So what I am suggesting is, if it is hospital wastewater intended to be reused for gardening, then they must go for ultrafiltration and UV. If the wastewater source is conventional, like only people, like an IT park or something, then there is not much of risk in using it for irrigation.
Okay.
So we just have to look at the application. What is the source?
Okay.
What is the intended use? Suppose since yours is a factory, you are blessed, you are there in an area where there is plenty of water. You are in Godavari belt, right?
Yeah. Yes.
Let us say you are in a water-starved city like Bangalore. You have to reuse the water. Then what you can do is, you want to use it for toilet flushing or cooling tower or HVAC or boiler feed. Okay. Then what you need to do is treat the water in a conventional STP, then push it through ultrafiltration so that more suspended solids are removed, more bacteria is removed, then use it for cooling tower or HVAC or boiler feed.
Yeah.
So based on the reuser, where you intend to reuse, one rule will not fit everywhere.
Okay.
Okay. And based on this, which technology is suitable? Based on my reuse pattern, what is my treatment objective? This is the first question we ask every client whenever they approach us for a treatment plan. The first question we ask is, why are you treating this water? Where do you intend to throw this water? Even if you are throwing it away. See, if it is a large project, 500 KLD, 1000 KLD, in such places, even throwing away of so much of water is also a challenge. Right? Anything more than 100 KL, discharge is a challenge. Please understand this. If you are landlocked, there is no drain point, then throwing away is also a challenge. And in places like Karnataka and Bangalore, especially Bangalore, NGT does not allow you to, National Green Tribunal does not permit you to throw away even treated sewage. They are putting condition that you have to reuse 100%, which is actually not practical. You can use it for toilet flushing, number one. Then remaining water, what can you do?
Yeah. Again, we have to reuse them.
Reuse where? If we have to reuse so much of water, it has to be again passed through an RO system where RO permit is used for bathing, etc. And RO reject can be used for toilet flushing.
Correct. Again, same thing.
But in an apartment complex, is it possible to have a sewage treatment plant with UF, RO?
No.
The cost will go up.
Yeah.
The manpower cost will go up. These are the challenges. So whenever somebody is asking us for a treatment plan, the first question we ask is, what is the objective? Do we have to reuse? What are the compliance requirements? See, 99% of the time, people set up a treatment plan because you have to follow the PCB norms. So then first question is, what are the PCB norms for you in your area?
In our area.
See, PCB norms are different from location to location. Let us say Kerala has BOD limit of 5, Karnataka has BOD limit of 10, Andhra Telangana have BOD limit of 30. Right?
Okay.
So where are you from is a question. Each area has different norms.
Correct. Correct.
CPCB guidelines are typically up to 30. But again, state pollution control boards have their own norms. Kerala has
even
the
in
highest.
Maharashtra also, in specific areas, they are specifying less than 20 and other in less than 30, sir. So in that way it is. Sir, one question from Ananta, sir. Two questions he asked. What is the effectiveness of SAF media over MBBR media? Other question is, what is anoxic tank condition retention time required?
Okay, let me answer the first question. SAF media, SAFF.
Yeah, yes, sir.
Okay. When you are saying the word, using the word SAF, SAFF, suspended aerated fixed film attached growth, right? Versus MBBR, moving bed bioreactor. Like we discussed in the presentation earlier, people started with extended aeration. That means there was no media in tank. All the bacteria was suspended in water. So people started putting some media to increase the surface area. This media was primarily plastic sheets. When you put a plastic sheet in water, it creates a surface area for the bacteria to attach and grow. So the concept of attached growth has started. Now the disadvantage of a fixed media was the plastic sheet is lighter than water. It tends to come out, come above the water. Okay. Now, over a period of time, bacteria, more and more bacteria is coming and latching onto the uh, uh, SAF sheet. It is becoming difficult for the sheet to remain in water. Initially, it is a challenge to hold it in water. Over a period of time, let us say 2-3 years later, it is a challenge to hold it in water. It falls down. It becomes heavier and falls down into water. So a more improved version came up in the form of MBBR media, which is circular, right? And which is self-cleaning. When the air is coming from the bottom of the reactor, this MBBR media is rotating because it has some small gear-shaped part around circle kind of things. It rotates in water and any excess bacteria is automatically detached. So MBBR media is self-cleaning. SAF media is not self-cleaning. SAF media is older version. Today, I am not seeing any applications where there is SAF media usage. And SAF media removal is a big challenge. MBBR media does not need to be removed. You just have to keep adding because there is some small percentage of breakages over a period of time. Every year, maybe 1 to 2% breakage will be there. So MBBR is a more advanced version compared to SAF. First question. What is the second question, Kishore?
What is anoxic tank condition retention time required?
Okay. The anoxic means it is not anaerobic, not aerobic. Maybe if you are just allowing your aerated water into a tank where there is no aeration, it is called anoxic, right? Every MBR tank, why anoxic is required is anoxic primarily helps you remove nitrogen. And nitrogen and ammonia removal are very important in today's PCB norms. These are called biological nutrient removal, BNR. BNR is not possible with conventional MBBR process. So by adding one more tank in the beginning of the process, that is an anoxic tank, right? So from collection tank, water comes into anoxic, the anoxic overflow goes into aeration. Okay, sometimes circulating a small quantity of sludge from settling tank into anoxic tank also helps more removal of ammonia, nitrogen, a small removal of phosphate. So what is the retention time? As per CPHO manual, if you have any doubt how to design a sewage treatment plant, CPHO manual is a Bible for sewage treatment plant. 2 hours is the typical retention time in an anoxic tank.
Yes, sir. Anantagaru, is that I hope you have understood, sir. Your 2 questions been answered. Thank you.
Yeah, if you need that particular CPHO manual, you can go to our website modernstp.com. You can download CPHO manuals. You can also go to Ministry of Urban Development website and download from there. One of these two,
Sir,
whichever
it
is
is
convenient, you can do it.
mandatory to have the anoxic tank in STP?
Any new STP needs to have lesser in the treated water standard I'm talking about, ammonia and nitrogen. Ammonia and nitrogen lesser quantity is possible only if you add anoxic tank. If it is MBBR process, anoxic tank is essential. If it is SBR, anoxic operation happens automatically because it is called what is called a pre-aeration tank. And a lot of sludge is already there. So you are mixing aerated sludge with fresh aerated water with fresh sewage. So anoxic reaction automatically takes place in a SBR. SBR does not need separate anoxic tank. MBBR needs a separate anoxic tank.
So it should be recommended by PCB.
No, PCB does not recommend you any treatment process. They will only say, we want water of this quality. How you get it is your problem.
Okay. Thank you.
Thank you. Thank you so much, everybody. Have a wonderful weekend. Enjoy your weekend. Bye-bye.
Thank you, everyone. Thank you all. Yeah.
Thank you. Bye-bye.
Thank you, Darshanji. Thank you.